3.2 is called Predicates and Quantified Statements number 2. So in this section, we're going to continue discussing the predicates and quantified statements that we started in the earlier section. But then we're going to also we're going to learn some rules for negating quantified statements. And we're going to look how to negate for all that exists and or quantifiers. First rule we want to understand is how to negate a universal statement. When we have this universal statement, which is for every x in D, Q of x, and we want to negate this, its negation will be equivalent to this form. For all x in D, we're going to negate this as there is some x in D, or you can say at least there is one x in D such that not Q. So we're changing Q to not Q, and then this for every x in D is changing with at least there is one x in D such not QX. So symbolically, this is the universal statement. When you want to negate this, this is the symbol to negating it. So this upside down A is going to change this with weird looking E. And then Q of X is going to change with not Q of X. So the negation of a universal statement, which is all, is equivalent to an existential statement, which is some are not, or there's at least one that is not. Now, if we look at the opposite case, if we're going to take the negation of an existential statement, so existential statement is with this weird E symbol. In English, it means there is at least one x in D such that Q of x. And when you want to negate this now, there is at least one x is going to change with every x in D. So its negation is every x in D, and then the negating of Q of x will be not Q of x. So symbolically, when you have this statement and you want to negate it, this everything, there is at least some is going to change with all, and Q of x is going to change with not Q of x. Therefore, the negation of an existential statement, some, is logically equivalent to none or all are not. So we have to know these important rules for the homework questions. For example, when we have this question, all primes P is odd. And then we want to negate this sentence. So all primes P is odd. Its negation is there is at least one P that it is not odd. So therefore, this symbol upside down A is going to change with this weird looking E, and then is odd is going to change with is not odd. When we look at part B, there is at least one triangle T such that the sum of the angles of T equals to 200. So when I want to negate this, instead of this, there is at least one triangle. I have to change I have to change this with none of the triangles or all triangles. So all triangles T, the sum of the angles T does not equal 200, because for this quantifier, its negation is this upside down A. Let's look at another example. When we have no politicians are honest and we want to negate this, we can just say that there are some politicians that they are not honest, right? So no politicians are honest. Sorry, for this sentence, we can just convert this to a formal version as for all politicians X is not honest, because no politicians will be changing as not honest. And then when we want to formally negate this for all politicians, we're going to change this with there's at least one politician X such that X is honest. So when we have the negation of universal conditions in those statements, remember the conditional statement is if P then Q, we call this as a conditional statement. And then when we want to negate this, we have to be very careful. So for every X, if P then Q, this is called the conditional statement. And when you want to negating this, its negation is going to be P of X and not Q of X. Because if you remember, this part, the conditional statement part, we learned this in earlier section that it is the same thing as not P or Q. So when you are negating it by using the De Morgan's law, you're going to get P and not Q. So this will be on more questions. Any conditional statement will be negated using this rule. So if we give the rule in a box here, for every X, if P then Q of X, and you want to negate this, this is how you show that you're negating this universal conditional statement. So every X is going to change with, there will be at least one X or some X such that P of X and not Q of X. So let's take a look at this question. Write a formal negation for statement A and informal negation for statement B. So here is a question. For every person P, if P is blonde, then P has blue eyes. Remember, so this for every person P is going to change with, there's at least a person P. So this upside down A is going to change with this weird looking E, that P is blonde, and we're going to change this with and we're going to negate this part that doesn't have a blue eye. So this is how we're going to change it. P is blonde and P doesn't have blue eyes. Now, if you look at the second part, if a computer program has more than 100,000 lines, then it contains a bug. Now, this is a if and S statement. Its negation statement will be, there's at least one computer program that has more than 100,000 lines, and it doesn't contain a bug. So it's and, not Q. P and not Q is its negation rule. So there are some rules with, for every X, there is some X and then OR, and you can read these from the book. There's some vocabulary that they're trying to explain you. And we need to look at the variance of universal conditional statements. When we consider a statement of the form of this, for every X in D, if P of X is then Q of X, if you remember what is a contrapositive, what's a converse, and what's an inverse is, its contrapositive is if not Q, then not P, and these two are logically equivalent. Its converse will be Q of X, then P of X, and its inverse is not P of X and then not Q of X. So when you want to write a formal and informal contrapositive, converse, and inverse for this following statement, so let's look at the statement. If a real number is greater than 2, then its square is greater than 4. So its formal version is, for every X in real numbers, if X is greater than or equal to 2, then X squared is greater than 4. So this is why we change this English sentence to a formal logical notation. So for contrapositive, we want to negate the conclusion, and then we have to include the then, and we have to negate the hypothesis. So we're going to say, for contrapositive, we're going to say if X squared is less than or equal to 4, then X is less than or equal to 2. In English, it means the same thing. If the square of a real number is less than or equal to 4, so when we are negating it, we're changing greater than or equal to 2 and less than or equal to 4, then the number is less than or equal to 2. So this is how we're negating it, because its negation rule is like this. For converse, when we have this question, same thing. If X squared, so for the converse, if QX, then P of X. So when we are writing this, we're going to write if X squared is greater than 4, then X is greater than 2. And for inverse, we're going to negate the first part and then we're going to negate the second part. So we need to say if x is less than or equal to 2 because its negation is less than or equal to 2, and then its negation for the second part is x squared minus 4. So these are the definition for this section. The definition of these terms can be extended to universal conditional statements. So we have to know that these rules for the homework questions as well. So we have to know these rules in boxed for homework questions. Now, if we just summarize what we're learning here, when we have all R have property S, and you want to negate this, so instead of all R, we're going to use there's at least one R, or there is some R that doesn't have the property S. That's the negation. When you have some R have property S, for some, its negation is all have all don't have property S, or you can just say no R have property S. When you say for every X, if X has a property P, then X has property Q, and you want to negate this, and this is an if and else statement. So instead of for every X, we're going to change this with there's an X such that X has a property B and X doesn't have a property Q. This is a rule we learned how to negate an if and else statement. The converse of for every X, if X has a property P, then X has property Q. So for this sentence, the converse will be for every X, if X has property Q, then X has property B. This P, this is how we write its converse. For contrapositive, for the same sentence, we're going to write for every X, if X doesn't have a property Q, then X doesn't have the property P. And for inverse, we're going to say for every X, if X doesn't have property P, then X doesn't have property Q. And this is a summary of 3.2. So for now, homework questions, 3.2, I made a mistake here. This is a 3.2 homework questions that I would like to discuss with you. For questions A through B, we are going to negate these sentences. All dogs are friendly. So I know that all is going to change with some or there's at least one. So either some or there's at least one is how I negate the all statement. So all dogs are friendly, but its negation is there's at least one dog that it is not friendly, or there are some dogs that they are not friendly. So now this is gone too because they didn't negate the friendly part. So I'm going to choose the correct answer as D here, because there's at least one dog, unfriendly dog. So this is how we write the negation for this question. When we look at part B, all graphs are connected, and we want to negate this. Again, for all, its negating is either some, or there's at least one, or there's at least one graph. So I know that answer will be one of these three, and all graphs are connected. So it's or negation is disconnected. So for this question, I'm going to choose again B, because there's at least one graph that is disconnected. It will be its negated statement. So some suspicions were substantiated. So some suspicions, its negation will be all, right? So answer will be either the first one or the second one. And for this one, its negation is unsubstantiated. So for this question, we're going to choose the second one as the correct answer. Now, for this one, some estimates are accurate. So the sum estimates is going to change with all estimates, right? Because its negation is just all estimates. And for accurate, its negation is inaccurate. So I'm going to choose this one as the answer. When you have the sentence, some estimates are accurate, its negation will be all estimates are inaccurate. And this is how we're going to do the first question on the homework. The second question on the homework is, we have a statement and we have a proposed negation is given, and our job is to decide if the negation is correct, or if not correct, we want to pick the correct negation. So statement is the product of any irrational number and rational number is irrational. So what we're saying is when we multiply an irrational number by a rational number, the result will be irrational number, right? So this is not even saying, it doesn't say that it's actually talking about for all cases, when you multiply an irrational number by an irrational number, the result is irrational number. So for the proposed negation, they said the product of any irrational number and any rational number is rational number. So I do see that they did negate the irrational with rational, which is a good thing, but they haven't done anything about the first part of the statement. So I know that this is not correct. So answer will be one of these four statements. And then they're suggesting some corrections here. So even though they don't say it's all cases, this statement implies all cases. So its negation will be there will be at least one case, or there are some situations, right? So the answer will be one of these. There is at least one. There exists at least one. So it is not going to be this one. Okay. And then I'm thinking that the correct answer is going to be this one, because there's an irrational number and a rational number whose product is rational. So instead of saying all the cases, its negation will be there are some cases of multiplying irrational number by a rational number whose product is, and negating this will be irrational. So the answer will be this one. Well, the next question on the homework, we have a domain given. And for this domain, we're going to decide if all these predicates are given as a true or false statement. So this one says, for every x in this set, if x is an odd number, x is greater than 0. So let's take a look at if x is an odd number. So this is an odd number, this is an odd number, and that's all I am saying is an odd number. And then 1 and 23, both of them are greater than 0. So this one is true. Now, for the next part, for every x in D, if x is less than a 0, so there are three numbers that are less than a 0. So negative 48, negative 14, negative 8. These are the only three numbers that are less than a 0. And x is an even number. And for all these three numbers, they are even numbers. So even this one will be a true statement. For part C, if x is even, then x is less than or equal to 0. So let's see, the even numbers are negative 38 is even, negative 14 is even, negative 8 is even, 0 is even, odd number, this is an even number, odd number, even number, and even number. So I underline all the even numbers. And this statement is saying that if it is an even number, then it is a 0 or less than a 0. But what about these numbers, 16, 26, 32, and 36? So this will be false, right? And then it says, once you decide that it is false, you have to give a counterexample. And one of the counterexample I can give them is 16 is an even number, but it is not a negative number. So for the next one, it says for the same set of sets and numbers, if the ones digit is 2, then the tens digit is 3 or 4. So let's look at the numbers that we have. The ones digit as 2. Ones digit as 2 is there's only one number, 32. This is the only number, 32. Then when I look at the conclusion, then the tens statement can be a 3 or it can be a 4, 3 or 4. And this is true because we have a 3 in our tens digit. So this will be a true statement because it says it can be 3 or it can be 4. Last one, for the same set, if the ones digit is 6, then the tens digit is 1 or 2. So if the ones digit is 6, so I see that 16 has 6 in the ones digit, and then we have 26, 6 is in the ones digit, and we have 36, 6 is in the ones digit. And when I read the statement, if the ones digit is 6, then the tens digit is 1 or 2, but what about 36? So we're going to say false, because we have also 36 for this question, and this will be the counter example for this one. For the next question on the homework, question 4, or 5, I don't know the correct order. So we have this statement for every integer d, if 6 over d is an integer, then d is equal to 3. Which of the following is a negation for this statement? So for the negation, we're going to negate this sentence. Remember, for every integer d, so this is an if p, then q. We studied that its statement will be p and not q. We talked about this before we started the questions. For this if and else statement, its negation will be if p and not q. So the correct answer will be here, this one, right? If more than I was looking at the wrong question. So the question 4 on the homework is, we have this statement for every integer d, if 6 over d is an integer, then d is equal to 3. And for number 4, all we have to do is negate this statement. And remember, for every integer d, its negation will be at least there is one integer d. So I know that the answer will be one of these two, but because this is what happens when I negate the first part. And then whenever we have if p, then q, and we want to negate this, we learned that the rule is p and not q. So that's what I need to choose from the answer choices. And in this case, p is 6 over d. So 6 over d, such that 6 over d is an integer. So it's going to stay the same. 6 over d is an integer. I'm going to use and. I'm going to negate this. D is not equal to 3. So the correct answer for this one will be B for this question. And this is how we do number 4, negating the statement. But for number 5, for this question, we are going to actually talk about the contrapositive, and we're going to decide if the contrapositive is true or false. And we're going to answer the questions in so many parts. So we have the same statement, but this time the question is asking me to find its contrapositive. So for contrapositive, if you look at your notes, for every integer of d, if 6 over d is an integer, then d is equal to 3. For contrapositive, we're going to say not q, not p. So the one which says not q, not p will be this one. So for contrapositive, this statement is going to change into, for every integer d, if d is not equal to 3, then 6 over d is not an integer. And this is how we set up the contrapositive, because the rule for contrapositive is not q, not p. Now, is the contrapositive true or false? Enter a value for d that can help you to answer this question. So let's think about this. If d is not equal to 3, then this is not an integer. Is it really? When I use 4, 6 over 4 is not an integer. It's 1.5. They're right. But is that the only thing? What about I use 2? So I'm going to say that this is a false statement, because look, when I enter 2 for d, 6 over 2 is still at 3, because 6 has 2 divisors, 3 and 2. So if d is not 3, d can be 2, and it will still give me an integer. But the question is now continuing saying that when you substitute this value for d, which of the choice below answer the question? So we're going to say the contrapositive is false, because the counterexample, 2 is a counterexample, for the given value of d, if d is not equal to 3 and 6 over d is still an integer, so the contrapositive in this case is false, because we have a counterexample given in this problem. Now, the next part of this question is, we want to write the converse of the statement. We need to write the converse of the statement. And for the converse of the statement, we need to remember the rule. The answer will be this one, because the converse is P. So remember here, if 6 over D is an integer, then D is 3. So its converse will be Q then P. So we're going to choose for every integer D, Q is D equals 3, then 6 over D is an integer. And this is how we're going to do its converse. Now the thing is converse true or false? Let's think. If D is equal to 3, then this is integer. So for this one, when we plug in a 3 here, 6 over 3 is 2, which is an integer. So we're going to say that this is true. Converse is true. And we don't have to find a counterexample for this since it is true. Now, next part is we're going to find the inverse of the statement. So we have to remember how to find the inverse of a statement. The rule for the inverse of a statement is not P, then not Q. So we are going to choose this answer for every integer D. If 6 over D is not an integer, because we're negating the first part, and then we're going to negate the second part. So the correct answer will be this one. For every integer D, if 6 over D is not an integer, then it's not a 3. So let's think, is it true or false? If this is not an integer, then it's not 3, correct? Because if it was 3, it will be an integer, so this will be a true, this inverse will be a true statement here for this question. So that's how we do this question. Now, the next question on the homework is, which is question 6. We need to decide if this is true or false. All occurrences of the letter U in discrete maths are lowercase. Choose the answer that explain your reasoning. So we're going to decide if this is true or false. And the statement is, all occurrences of the letter U in discrete mathematics are lowercase. Choose the answer that explains your reasoning. This one in the book is, you can read in detail, it's about being viciously true. So we're going to choose that this is true. There are no occurrence of the letter U in discrete mathematics. So this one is called viciously true. So we can read this term in detail from the book. For question 7, the homework is asking us, we have this statement, passing a comprehensive exam is necessary condition for obtaining a master's degree. We are going to choose the correct answer that this statement is in an if then form. So which of the following correctly expresses this statement is an if and then form, and there might be more than one answer. So passing a comprehensive exam is a necessary condition for obtaining a master's degree. If a person does not pass a comprehensive exam, then the person cannot obtain a master's degree. This is correct, right? And then this is not Q, this is not P, then not Q. Not P and then not Q, which is the inverse, and it's correct. Now, if a person passed a comprehensive exam, then that person obtained a master's degree. But its necessary condition does not guarantee that it's going to obtain a master's degree. So this is not going to be correct. If a person does not pass a comprehensive exam, then that person can obtain a master's degree. This is not correct. If a person cannot obtain a master's degree, then that person passed the comprehensive exam. This is also not if then form. If a person obtained a master's degree, then the person passed a comprehensive exam. So this is correct because if Q then P is the acceptable case here. And now we have the, I believe, last question on the homework. And the question has a reminder for us. We need to remember that whenever we're negating for every X statement, and there exists some statement, that the negation of an if-then statement is an and statement. So what we are saying that whenever we have if P, then Q, and we want to negate this, it's negation. So this is what negation means. And then when I want to negate if P, then Q, we have a rule that we learn. Its negation will be P and not Q. P and not Q. Not Q. So having a large income is not necessary condition for a person to be happy. Having a large income is not a necessary condition for a person to be happy. So even though this one doesn't say that for every person who is having a large income, having a large income is not a necessary condition for this person to be happy. For this one, the correct answer will be there's a person who doesn't have a large income and is happy. So we're changing not happy to be is happy, and we're using and then we're keeping the same part the same, who doesn't have the large income. So we're going to choose this one for the necessary and sufficient. Correct answer is which of the following expresses the statement without using the words necessary or sufficient? So when you remove the necessary, this is going to be there's a person who doesn't have a large income and is happy. This is how we're going to answer this question in the homework.